So for this last video in the chapter, we're going to talk about functional groups. This is a bit of a change of pace from the rest of the chapter where we talk about acids and bases, and this will be a good sort of intro chapter actually to chapter 3 when we start talking about hydrocarbons actually in a lot more detail. So firstly, before we start talking about functional groups of hydrocarbons, what actually are functional groups? Right, so functional groups are a characteristic group of atoms. All right, it's a way for us to talk about parts of a molecule rather than just say, oh, here's a carbon, here's an oxygen, oh, this thing next to the nitrogen. So it'll allow us to talk about molecules more succinctly than we've been able to. Okay, so for the first group of hydrocarbons, let's talk about alkanes. So alkanes are hydrocarbons with single bonds. Right, so for an example, this one with just 2 carbons, right? So the Lewis structure for this is all we'll be drawing here, right? But this is just an example of a hydrocarbon, right? Carbons with only single bonds, right? Just sp3 carbons. And so if we were to instead have a double bond, what would that be called, right? So hydrocarbon with double bond. As you can imagine, it would look like this. Right, so this is an alkene. Okay? And now what about a triple bond? So in the case of an alkyne, this is a hydrocarbon with a triple bond. Right, so these sp carbons. Just like this. Okay? And this can refer to any part of a molecule. So if you have a huge carbon chain and there is a triple bond in it, you can say this part of a molecule is an alkyne. All right, so this can be referred to with any portion of a molecule, right? Not just the whole thing. And so for another example, what if the hydrocarbon was in a ring, right? So we would say cycloalkane, right? So hydrocarbon in a ring, right? Just for ease of drawing, I'm not going to do the Lewis structure, but I'll just show you, right, an example like this, right? With each of these bends here being CH2 carbons, right? So this is cycloalkane, right? All these singly bonded carbons form together in a ring. So there's one last one in the hydrocarbons I'd like to talk about, and that is an aromatic group, right? Or you can just call it aromatic. So kind of similar to the hydrocarbon example, this is a series of double bonds in a ring. Right, and that's going to look like this. Right, this is the most common example of an aromatic group you'll see. And for the most part, this is the one that we're seeing 99% of the time, right? So all these double bonds together in a ring, right? Remembering that resonance from previous video example, right? These double bonds can sort of flow across this ring together. Okay, so this is an aromatic ring, right? All these double bonds right next to each other in a ring formation. So you can see my notes here I've got to erase. So how do we go to further define alkanes, right? And we're going to talk a lot about this next chapter, but I kind of wanted to introduce it to you here, okay? You probably noticed a lot of them sound the same, like alkane, alkene, alkyne, and a lot of these have the ane suffix, right? And what that's sort of telling us, right, is that we can sort of define these accordingly, right? So instead of just having alkane, right, which is just the general term for these hydrocarbons, we can define it further, right? And we can change the prefix of the name to indicate how many number of carbons there are, right? So we have a little chart here that I've kind of shown, right? So meth is 1 carbon, eth is 2, prop is 3, bute is 4, and so on. Right, so for example here, methane, just drawing out the Lewis structure, not worrying about 3D space, right? Just 1 carbon. Supposed to draw propane. We have 3 carbons. I'll talk about this again early in the next chapter, but it's good to sort of familiarize yourself with it now. Okay, hexane, I'll do line angle because I'm lazy to draw everything out. Right, there are 6 carbons there. It's important to know that these are all alkane. Right, these are all alkanes. Right, we can just define them further by naming them. Right, so this is methane. This is propane. This is hexane. Okay. So next, let's talk about functional groups with oxygens. Okay. So there's a lot of different molecules that contain oxygen. So we'll talk about kind of the major ones for now. So let's start with probably the one that comes to your mind first. So let's talk about alcohol. Right, so alcohol groups. You probably also heard it called hydroxy groups. These are any molecule that contain, right, this OH functionality. Right, any molecule with an OH on it is considered an alcohol. Okay, so for example, if we remember our example with ethanol, we would say that this group, right, is an alcohol. So our next example, let's talk about ethers. So an ether group is any group that looks like this. An oxygen with 2 things bonded to it that are not just hydrogens. Okay, that's kind of an important distinction here. And you notice that I've used R here, and what R means is just any alkane-based group. Okay. So for example, if I was to draw an ether, just like this. So this compound here is an ether. You notice from the top example, right, with ethanol, you notice there is one alkane group over here, right, this hydrocarbon group, but this is not considered an ether, right, because it has an OH group on it. So this is automatically an alcohol, okay? So likewise, there's no hydrogens on this oxygen, so it's not an alcohol, so instead it is an ether. And so for our next example, we're going to talk about a ketone. Okay, and a ketone is as follows. Like this. So it is this carbon double bonded to an oxygen, okay, and it has these 2 alkane groups attached to it. And something important to note here too is that this oxygen double bond, we can call this a carbonyl, okay? But we can further define it, okay, as a ketone, right? So this whole thing here is a ketone. similarly, an aldehyde is like this, right, where we have a hydrogen now on that carbon. Okay, there's an important distinction here, right, because that changes, and we'll get into this in a later chapter, but the hydrogen here changes the reactivity of the carbon-oxygen double bond, right, that carbonyl. Much different than the ketone is with two carbons attached to it. All right. So another example is a carboxylic acid. Okay, and the carboxylic acid looks like this. Instead of attached to a carbon or a hydrogen, we instead have an OH group. Okay, so we wouldn't consider this an alcohol, right? It does have an OH group, but more importantly, it's attached to a carbonyl. Okay, so this sort of takes priority, right? We don't want to be naming things within things. Like we couldn't call this an alcohol and then call this whole thing a carboxylic acid, right? Carboxylic acid takes priority here. So anywhere you see this sort of functionality, we would call it a carboxylic acid. Okay. And similarly, I'm going to erase this portion right here, give myself some more room. Finally, we have an ester. Okay. And an ester looks as follows. So instead of having the oxygen bonded to a hydrogen, it is now bonded to another alkane group, okay, a hydrocarbon group. And it's different, right? Much different than an acid, right? Because as you can imagine, they have very different pKa's, right? The pKa for this is going to be way lower, right? It's going to be acidic. And this is going to be virtually not acidic, okay? So that really changes their functionality. All right. I hope this makes sense, and we'll get into some practice with actually naming these things out, okay, in a little bit. And this is sort of one of these examples of having to memorize, right, the names. There's not really much rhyme or reason to the names, right? So this will just be one of those situations where we'll just have to, memorize these to the best of our ability. And so for the last example of functional groups, we'll talk about things with nitrogens, okay? So first off, we'll talk about amines, okay? And amines are as follows. So anything generally with a nitrogen single bonded to other things, right? So these can all be considered amines, okay? And the important thing to note here, right, is just because, depending on whether you have a hydrogen or an alkane group, it doesn't change that it is an amine, okay? And we'll talk a little bit more about that later down the line, but this is an amine group, okay? And we'll get a little bit more practice with recognizing them down the line. So next we have an amide, or an amide, depending on which part of the country you live in. So an amide looks similar to a carboxylic acid, but instead of being attached to an oxygen, is instead attached to an amine. Okay, so this is how amides typically look. Okay, could also be a situation where it could be attached to something else, right? Another alkane group, but this is still considered an amide, all right? For the last example, we'll talk about nitriles. And this is simply carbon triple bonded to a nitrogen. And the carbon could be attached to anything else, alkane, hydrogen, but the defining feature is this carbon-nitrogen triple bond. Okay, so this is a nitrile group. You might also have heard it called a cyano group as well. So the nitrogen list is a lot shorter. This is basically it for nitrogens. And we can talk a little bit more about them in greater detail, but we'll do that in a different chapter. But it's just to sort of get you guys initially familiarized with the different types of functional groups, okay, and recognizing them when they appear, okay? So for an example we'll do in class, and I think this will be some good experience, go through and identify 6 different functional groups in this molecule. Right, so go ahead and circle them and list what they are. You can do every single one, if at all possible, but try to get at least 6 different functional groups. All right.